Welcome back to Mateo Valley Calculus Tutorials. Today we're going to be teaching you about U-Substitution. And U-Substitution is a way to evaluate antiderivatives and integrals in ways that you couldn't normally do it with the normal antiderivative rules. So we'll start off with a problem. The integral of 2x plus 2 times e to the x squared plus 2x plus 3 with respect to x. Now, with the normal antiderivative rules, this isn't something that you could normally solve. But through U-Substitution, you can solve it. U-Substitution takes something in a form that you don't know and puts it in a form that you do know, and then it allows you to use the normal antiderivative rules to solve for the integral. So here, we would make u equal to x squared plus 2x plus 3. du would be equal to 2x plus 2. Then you'll multiply over the dx, and you get that du is equal to 2x plus 2 dx. Now, you have a 2x plus 2 and a dx, therefore you can substitute in the du and make this into a U-substitution problem. So, when you substitute in all the u's, you get the integral of e to the u du, because u is exchanged for this part, and du is exchanged for this part, and for this part. So e to the u du is something that you know how to solve. The integral of e to the u is just e to the u. Now, obviously this isn't the antiderivative of this, so what you need to do is you need to plug u back into this integral. So you get e to the x squared plus 2x plus 3, plus a constant. Now, if you want to check, you can always rederive this. So, by normal derivative rules, e to the x is e to the x times x prime. So it's e to the x squared plus 2x plus 3 times 2x plus 2, which is the derivative of this. And the plus c, which is a number, just goes away because the derivative of a horizontal line is 0. So, now we'll try a different problem. We'll try the integral of 4 cosine 3x with respect to x. So, according to integral rules, if you have a constant multiplied into the function, you can take the constant out. So now we have 4, the integral of cosine 3x dx. Now, we don't know how to integrate cosine 3x with the normal antiderivative rules. So, with U-substitution, we could change it into cosine of x, cosine of u. So you make u equal to 3x, because that's where you want the u. Then you derive that, and you get that du over dx is equal to 3. So you get that du is equal to 3 dx. Now, you don't necessarily have a 3 in here, but for integrals, you can multiply in constants. You can't multiply in functions such as x or x, but you can multiply in constants. So you can multiply into 3, but in order to do that, you also need to multiply in a 1/3 on the outside, because you can only multiply by a sneaky form of 1. So, by doing this, you have 4/3 the integral of cosine u du. Now, cosine u du is something that we know how to integrate. The integral of cosine is sine. So now we have 4/3 sine u. Now we plug this u back into here, and we get 4/3 sine 3x plus c. Now, to check if it comes back in here, just derive this. So this is just a constant out in front, and according to chain rule, it's outside. So the derivative of sine is cosine. Inside stays the same, 3x, times the derivative of the inside, which is 3. This is multiplied by 4/3 from above, and the constant just goes to 0. Now the 3 here and the 3 here divide out to 1. So you get 4 cosine 3x, which is the same as it is up here. So that's basically what you're trying to do with U-substitution. Take something in a form that isn't solvable and put it into a form that is solvable.